Sample problem number 1. Assuming the concrete is uncracked, compute the bending stresses in the extreme fiber of the beam for a bending moment of 30-foot kip. The normal weight concrete has an FC prime or strength, compressive strength of 4,000 psi and a modulus of rupture of 474 psi. B. Determine the cracking moment of the section. So first, we have to account for all the given items in the problem. So first given are the dimensions of the beam. We start with B. B is 12 inches here. H is 18 inches here. D is 15 inches here. Now D is the distance from the extreme fiber on the compression side towards the centroid of the steel bars. So that is your 15 inches. FC prime is the strength of concrete, which is 4,000 psi. AS is given to be 3 square inches. Now, even if you don't know the area of the rebar, as long as you are given the bar number, then you can compute for the area of the rebar. For example, to compute for AS, we can say that this is 3 because there are 3 pieces here. We have 1, 2, 3 times the area of a single rebar. Now, what is the area? Area is, since the rebar is circle, so the area is pi d squared over 4. So, pi times d. Now, what is your d? You are given here number 9. So, to determine the d there, you have to divide the 9 by 8. Now, always divide everything by 8. Whether it's 9, 10, 11, 5, 6, 7, always divide it by 8. So, 9 over 8 squared over 4. So, that is your AS. So, if we calculate that, that will generate a value of 3.0 inches squared. Okay? Hence, this value here, the 3 inches squared. Then, we have moment. Moment is given to be 30 kip foot or foot kip. Then, we also have this lambda. This is equivalent to 1. Alright? And this is for normal weight concrete. So, let's now solve the problem. For the first problem, we are assuming that the section is uncracked. So, because the section is uncracked, the I, or the moment of inertia, is simply BH cubed over 12. BH cubed over 12. This is the formula. So, the answer is 5832 inches to the fourth. That is simply substituting the values above for B, which is 12 inches, H is 18 inches, and then cube the H and then divide it by 12. Okay? Next is value of your Y. What is your Y? Y is the distance from the extreme compression fiber to the neutral axis. Now here, it is obvious that since this section is rectangular, the neutral axis, or the axis where it is neither tension nor compression, is at the center of this beam. This one is your compression side, and below it is the tension side. So for the compression side, the value of your Y is simply 18 divided by 2. 18 over 2. Or that is simply equal to 9 inches. So to solve for the value of the stress or the F, no, FB or bending stress, it is simply my over Ig. Now, if you try to recall, in strength of materials, there is a basic formula for bending stress. FB is mc over I, where m is the bending moment, c is the distance from the neutral axis to the outermost compression or tension fiber, then I is your moment of inertia of the entire section. So in the same manner, that is also the formula that we are going to use here. So F is m times y over Ig. We have the value of moment, that is 30 kip-foot. Then y, we have 9 inches. And we have Ig, 5832 inches to the fourth. Now, one thing to note, please be careful in substituting the values. You have to be consistent with your units. For example, for the moment, the value here is 30 kip-foot. Once you plug in your values in this equation, your dimension should be in inches and your weight or force should be in terms of pounds. So to make the kip into pounds, you have to multiply it by 1,000 to make it pounds. And for the foot, you have to multiply it by 12. Okay? So 1,000 times 12, or simply 12,000. So therefore, this 30 here will be multiplied by 12,000 before plugging in the value to this equation, so that you can generate the bending stress. Okay? So just remember to multiply everything by 12,000 if your moment has a value which is having a unit of kip-foot. Okay? So calculating using Microsoft Excel, you can generate this answer, 555.56 PSI. PSI means pounds per square inch. Okay, as I said, for the kip, in order to make it pound, you multiply it by 1,000. For the foot, to make it inches, you multiply it by 12. Hence, we have here the 1,000 and the 12. So, the moment, multiply it by 30, by 12,000, multiply the 30 by 12,000, then plug in to this formula. Okay? So, try to review using your calculators. Next, determine the cracking moment of the section. So, we have here a formula for FR, or the cracking moment. This is 7.5 times lambda times the square root of FC prime. Okay? So, just plug in all the values. And lambda, this is a normal weight concrete. And for normal weight concrete, automatically the lambda should have a value of 1. So, 7.5 times 1 times the square root of 4,000. And you'll be able to generate this value, 474.34 PSI. And it is the same as here, 474.34. Only it dropped the decimal place. But it's just a little rounding off, and there is no problem in terms of the final answer. Next is Y tension. Now, why are we calculating the Y in terms of tension? Because we are assuming that the concrete has cracked already. Okay, the concrete has cracked already. So the Y tension now becomes still 9 inches, no? Because we are determining from the neutral axis, this is the neutral axis, to the outermost tension fiber here. So, since the neutral axis is at the center, of course, the distance from this neutral axis to the outermost tension fiber is also 9. Okay? So that will be 9 inches. So the cracking moment, now this is just a manipulation of this basic formula. FB is MC over I. So if you try to change that one, that will be leaving the moment on the other side. M is FB times I over C. Okay? Hence, we have here FR because we are going to use the rupture stress, because the section is already cracked. Then IG, the gross area of the section, and YT, which is the the distance measured from the neutral axis to the outermost tension fiber. Alright, so we get now an answer of 25.61 foot kip. Now, why is it in foot kip? Normally, if the required answer will be moment, the unit should be in foot kip. So therefore, whatever is the answer of this formula, simply divide everything by 12,000 and you will generate the answer, which is in terms of foot kip. Alright, otherwise the answer will also be in pound inch, and this will be a longer answer, having more values. But since you divide it by 12,000, the answer is 25.61. Alright, thank you so much.